Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. This second video lecture of week 7 for the course Applied Mathematics 1 is the continuation of my previous first video lecture of week 7. In the first video lecture, we have discussed implicit differentiation. Now, in this video lecture, we are going to learn about equation of tangent and normal line. For equation of tangent and normal line, we need slope of the tangent and normal line. And for the slope, we use the derivative. We use the implicit differentiation because the given function will be in the implicit form. So, dear students, note that the geometrical interpretation of derivative is slope of tangent and normal line. So, by using derivative, we can find the slope of tangent and normal line. And this is actually the application of derivative. By derivative, we can find the slope of a tangent line to a given curve. Now, let's see. You see over here, this is the graph of the given function. This curve represents the given function. Now, tangent and normal line. We often need to find tangents and normal to curves when we are analyzing forces acting on a moving body. A tangent to a given curve is a line that touches the curve at one point and has the same slope as the curve at that point. A normal to a curve is a line perpendicular to a tangent to the curve. So, dear student, you see over here in this plane, this is the given curve of the given function. This is the curve of the given function. And this line touches this curve at this M point. The M point has the coordinate x0 and y0. So at this point, this line touched the curve at only one point. So a line that touched the curve at only one point is called a tangent line. And this angle alpha is the inclination of this tangent line. Now, dear students, this is another line, and this another line is perpendicular to the tangent line at this 90-degree angle. So this is the normal line. A normal line is a line which is perpendicular to the tangent line. Now we need equation of this tangent line and equation of this normal line. For the equation of tangent line and normal line, we need the slope of these lines at this given point M. So for the slope, we use the derivative. We take the derivative of this given function, and this given function will be in the implicit form. So in the previous video lecture, we have already discussed that how to calculate the implicit differentiation. So in this lecture, actually this function will be given in the form of implicit. So first of all, we find the implicit differentiation of the given function at this point. So we calculate the implicit derivative at this function. We calculate the implicit differentiation at this given point M, and then we use that slope. Actually, when we calculate the implicit differentiation of the function at this point, it's give the slope of the given function at this point, and it's give the slope of the tangent line at this point. So we use the slope of this tangent line to the curve in this equation formula you see over here. This is the equation of tangent line to the curve at the given point x0, y0. Y minus y0 is equal to m into x minus x0, where this m is the slope of tangent to the given curve dy by dx. So dear students, the given function will be in the implicit form. So calculate the implicit differentiation at the given point x0, y0. This is actually dy by dx, and dy by dx is equal to m, and m is the slope of tangent line to the given curve. Now, equation of normal line to the curve at the point x naught and y naught is y minus y naught is equal to minus 1 over m into x minus x naught. Y, the slope of the tangent line is m, and the slope of the normal line is minus 1 over m, because we have already discussed that the normal line is perpendicular to the given to the tangent line. So when two lines are perpendicular, then their slopes are negative reciprocal of each other. So for example, the slope of the tangent line is m, then the slope of the normal line will be minus 1 over m. So dear students, this is the formula of equation of tangent line. Y minus y naught is equal to m into x minus x naught at the given point y naught, x naught and y naught. So point will be given, function will be given. So first of all, we calculate the implicit differentiation of the given implicit function at this given point, and then put the given point and the slope in this formula. We will find the equation of tangent line, and then put the negative reciprocal of the slope and put the point in this formula. This will be the equation of normal line. For example, you see over here, this is the given function y square plus x square is equal to y power 4 minus 2x. This is an implicit function, and we required slope of this curve. Now for the slope of this curve, calculate the implicit differentiation at this point minus 2 and minus 1. Minus 2 represent x naught and minus 1 represent y naught. Now y square plus x square is equal to y square minus 2x, y power 4 minus 2x. So first of all, find the implicit differentiation of this implicit function, taking the derivative with respect to x of y square plus x square, and the derivative with respect to x of y power 4 minus 2x. So using the chain rule for the y square, you see over here, the derivative of y square is 2y, and further derivative of the base dy by dx, plus derivative of x square is 2x is equal to derivative of y power 4, again using the chain rule, multiplied the power with the coefficient 4 into y power 3, and further derivative of the base dy by dx minus 2. Now shift dy by dx term to the left hand side and other terms to the right hand side. We obtain 2y dy by dx minus 4y cube into dy by dx is equal to minus 2x minus 2. Now taking common dy by dx from these two terms, we obtain 2y into 1 minus 2y square into dy by dx is equal to, taking minus 2 from this term, minus 2 into x plus 1. Now dividing both sides by this term 2y into 1 minus 2y square, we obtain dy by dx is equal to minus 2 into x plus 1 divided by 2y into 1 minus 2y square. So this implies that dy by dx, 2 and 2 cancel, minus into x plus 1 divided by y into 1 minus 2y square. Now this is actually the slope of the tangent line. Now this slope represented by m, and m is equal to this slope at this point minus 2 and minus 1, putting x naught is equal to minus 2, putting x is equal to minus 2 and y is equal to minus 1. In this expression we obtain the derivative, you see over here, m is equal to dy by dx is equal to minus into minus 2 plus 1 divided by minus 1. This is the value of y, minus 1 into, you see over here, putting the value of x minus 2, the value of y minus 1. So minus 2 plus 1 divided by minus 1 into 1 minus 2 into minus 1 whole square, and you see over here. Now after simplification, we obtain the slope dy by dx of tangent line is equal to 1. Now dear student, if we have another point x is equal to minus 2 and y is equal to 1, suppose this is another point, and for this point the slope is equal to dy by dx is actually minus into x plus 1 divided by y into 1 minus 2y square. Now how to put this point? Dy by dx is equal to minus, as it is, putting x is equal to minus 2 plus 1 divided by y value is 1 into 1 minus 2 into the y value is 1. So 2 into 1 whole square mean 1 multiplied 2 again 2. Now after simplification we obtain the slope is minus 1. Now the next problem is to find equation of tangent and normal to the given curve. The curve represented by this function y is equal to x cube minus 2x square plus 4x at this point 2 and 4. So this is represent x and this represent y. This 2 also represent x naught and 4 represent y naught. Now since we need equation of tangent line, in the equation of tangent line we need the slope m. So for the slope, take the implicit differentiation of this given function, differentiating this given function with respect to x. Now this function is also in explicit form, so the derivative is very easy. Dy by dx is equal to derivative of x cube minus 2x square plus 4 with respect to x. So dear students, you see over here, this is the derivative of x cube by using the power rule 3x square minus 2 into derivative of x square is 2x and derivative of 4 is 0. Now dy by dx is equal to 3x square minus 4x. So this is actually the slope of the tangent line to the given curve. Now putting this point x2 and y4 and this slope, so derivative at this point is equal to 3 into 2 whole square minus 4 into 2. Now 2 to the 4 and 4 3 the 12 and 2 4 the 8. 12 minus 8 is equal to 4. So the slope of tangent line to this given point is equal to 4. Now equation of tangent line to the given curve at this point 2 and 4 is by using the formula y minus y naught. This is the equation of tangent line formula. Y minus y naught is equal to m into x minus x naught. Now putting in this formula, m is equal to 4 and x naught is equal to 2 and y naught is equal to 4. This 2 represent x naught and 4 represent y naught, and slope m is equal to 4. So putting these values, you see over here y minus 4 is equal to 4 into x minus x naught. This is actually the x naught value and the y naught value is 4, and this 4 represent m. The value of m is 4. Now y minus 4 is equal to 4x minus 8, and this implies that y is equal to 4x minus 8 plus 4. So y is equal to 4x minus 4. This is equation of tangent line to the given curve. Now equation of normal line to the curve at this point. Now since normal line is perpendicular to the tangent line, so the slope of the normal line will be equal to minus 1 over m. So dear students, note that this point is very important. Since the slope of the tangent line is 4, so the slope of the normal line will be equal to minus 1 over 4. When two lines are perpendicular, then the product of their slope is equal to minus 1. So that's why when the slope of the tangent line is 4, then the slope of the normal line will be equal to minus 1 over 4. So in this formula you see over here, the y naught value is 4 and the slope minus 1 over m mean minus 1 over 4. This is the slope of normal line, and x minus x naught value is 2. Now to simplify this equation, 4y minus 16 multiplying both side by 4, we obtain 4y minus 16 is equal to minus x plus 2, and this implies that 4y is equal to minus x plus 2 plus 16. So 4y is equal to minus x plus 18, and this implies that 4y is equal to minus into x minus 18. So y is equal to minus 1 over 4 into x minus 18. This is the equation of normal line. Now another problem, to find the equation of tangent and normal to the curve x square minus 3xy plus y square is equal to 5 at this point 1 and 1. So dear students, now the function is implicit in implicit form. So first of all, for the equation of tangent line, find the slope And for the slope, we need to calculate the implicit differentiation of this implicit function at this point 1 and 1. So x square minus 3xy plus y square is equal to 5. Taking derivative of this implicit function with respect to x. So derivative of x square minus 3xy plus y square with respect to x, and derivative of 5 with respect to x, which is equal to 0. Now the derivative of x square by using power rule 2x, and for the derivative of xy we use product rule. So minus 3 as it is, into first function x and second function is y. So first function derivative of second function plus second function is it is, and derivative of first function plus now derivative of y square. You see over here derivative of y square with respect to x. Now 2x minus 3 into x dy by dx is it is minus 3 and y multiplied minus 3y, and the derivative of x is 1. So minus 3y is it is, and the derivative of y square using chain rule 2y, and further derivative of the base dy by dx is equal to 0. Now in these two terms dy by dx is common. So from these two terms taking common dy by dx, so 2y minus 3x into dy by dx, and shift these two terms to the right hand side 2x and minus 3y. So we obtain 2y minus 3x into dy by dx is equal to 3y minus 2x. Now dividing both sides by 2y minus 3x to obtain dy by dx. So you see over here dy by dx is equal to 3y minus 2x divided by 2y minus 3x. Now this is actually the slope of the tangent line. Now to calculate this slope at this given point 1 and 1. So putting x is equal to 1 and y is equal to 1 and this slope and this derivative. So dy by dx is equal to 3 into the value of y is 1. So 3 multiplied 1 3, and the value of x is also 1. So minus 2 multiplied 1 minus 2. So 3 minus 2 divided by 2 minus 3. Putting x1 and y1 in this expression, we obtain slope m is equal to dy by dx, and dy by dx is equal to 3 minus 2 divided by 2 minus 3, which is equal to 1 by minus 1, which is equal to minus 1. So this is the slope of tangent line. Now putting slope of minus 1 and point 1 and 1 in the equation of tangent line. Equation of tangent line is equal to y minus y naught. Y minus y naught is equal to m into x minus x naught. So this one represent x naught and this one represent y naught. So y minus 1 is equal to minus 1 into x minus x naught, and the x naught value is 1. So this implies that y minus 1 is equal to minus x plus 1, and we can write y is equal to minus x plus 1 plus 1. Shift this minus 1 to the right hand side. We obtain y is equal to minus x plus 2. So this is the equation of tangent line. Now equation of normal line. Now the slope of the tangent line is minus 1. So the slope of the normal line will be equal to plus 1, because the slope of the tangent line and normal line are negative reciprocal to each other, and the reciprocal of 1 is again 1. So in this problem the slope of tangent line is minus 1. So the slope of the normal line will be equal to 1. So you see over here minus 1 divided by minus 1. So the slope of the normal line is 1, and this is the normal line equation. Y minus 1 is equal to x minus 1, and this implies that shift this minus 1 to the right hand side. We obtain y is equal to x plus 1 minus 1. Minus 1 plus 1 cancel. So y is equal to x. Now another problem for the practice, to find equation of tangent in normal line to the curve 2x cube minus x square y plus y cube is equal to 1 at this point 2 and minus 3. So for the equation of tangent line, first of all calculate the implicit differentiation of this implicit function at this point 2 and minus 3. This will be the slope of the tangent line. So first of all find the slope of the tangent line by using the implicit differentiation at this point 2 and minus 3. So derivative of 2x cube minus x square y plus y cube with respect to x, and derivative of 1 with respect to x is 0. Now the derivative of x cube by using the power rule, 3x square, and for this x square y we need to use the product rule because these two terms are in multiplied form. These two variables are in multiplied form, x square multiplied y. So first derivative of second function plus second function and derivative of first function, and minus will be multiplied, so we obtain minus x square dy by dx minus y minus y, and derivative of x square again is 2x, and you see over here for the derivative of y cube using chain rule 3y square, and further derivative of y dy by dx. Now in two terms we obtain common dy by dx. dy by dx is common in these two terms, dy by dx and dy by dx. So these two terms will be on the left hand side of the equation, and other term shift to the right hand side. So this term will be on the left hand side and this term will be on the left hand side, and shift these two terms to the right hand side you see over here, and taking common dy by dx we obtain 3y square minus x square into dy by dx is equal to 2xy minus 6x square. Now since we need dy by dx, so dividing both sides by 3y square minus x square to obtain dy by dx is equal to 2xy minus 6x square divided by 3y square minus x square. Now this is the slope of tangent line. To calculate this slope at this point 2 and minus 3, putting x is equal to 2 and y is equal to minus 3, and this derivative, so dy by dx is equal to 2 into 2 into minus 3 minus 6 into 2 square. This is the value, 2 is the value of x and minus 3 is the value of y, divided by 3 into minus 3, value of y is minus 3 whole square minus x, and the value of x is 2, so 2 square. Now after simplifications we obtain 2 to the 4 and 4 3 the 12 and 4 6 the 24 divided by 3 minus 3 square mean 9, 9 3 the 27, and 2 square mean 4. So minus 36 divided by 23 is the slope of tangent line. Now equation of tangent line, by using the formula for the equation of tangent line, y minus y naught is equal to m into x minus x naught. So the m value is minus 36 divided by 23, and the value of y naught is minus 3. So y plus 3 is equal to m, and this is the value of m into x minus x naught. The value of x naught is 2. Now equation of a normal line to the curve at this point 2 minus 3. Since the slope of the tangent line is minus 36 by 23, so the slope of the normal line will be equal to 23 by 36. So dear student, this point is very easy. For this normal line, take the negative reciprocal of the slope of the tangent line. You can easily obtain the slope of the normal line, and you see over here the slope of the normal line is 23 by 36 because the slope of tangent line is minus 36 by 23. So the slope of the normal line will be equal to 23 by 36 because the slope of normal line and tangent line are negative reciprocal of each other. So equation of normal line is now y plus 3 is equal to minus 1 divided by m. This m represents the slope of the tangent line. Now into x minus x naught, and the value of x naught is 2. So we can write y plus 3 is equal to 23 divided by 36 into x minus 2. This is the equation of normal line for the given implicit function. So dear students, the conclusion of this lecture, note that actually we need the equation of tangent line and equation of normal line. Tangent line touch the curve at only one point, you see over here in the first slide of this video lecture, you see over here, this is the tangent line. Tangent line touch the given curve. This curve is the given function. This curve is the curve of the given function. So when we draw the graph of the given function, this curve will be obtained. So this is the curve of the given function, and we need equation of tangent line to this curve. Tangent line touch the given curve at this point M, and this point M has the coordinate x0 and y0, and another line is perpendicular to the tangent line. So this is the normal line. Normal line is perpendicular to the tangent line. So in this video lecture, we have discussed how to find equation of tangent line and normal line to the given curve. So for this purpose, the function is given and the point is given, and in the equation of tangent line, we use slope y minus y naught. Y minus y naught is equal to m into x minus x naught. So x naught and y naught is already given, but m is not given. This small m represent the slope. So first of all, we find the slope m. This slope m is actually dy by dx. So this is the application of derivative. By using derivative, we can find the slope of the tangent line to the given curve. So first of all, find the derivative. And in this problem, most of the problem will be in the implicit form. So if the problem is in implicit form or in explicit form, we simply calculate the given function. We simply calculate the derivative of the given function. So first of all, find the derivative of the given function and then put the given point in the derivative. We will obtain the derivative of the given function, and this will be the slope of the tangent line to the given curve. So first of all, find the derivative of the function at the given point. When we find the derivative, then put the given point in the derivative result. So we calculate the derivative and then put the slope. When we calculate the derivative of the given function at the given point, this will be the slope of the tangent line. So putting the slope m in this formula and putting x0 and y0 in this formula, we will obtain equation of tangent line. And for the normal line, take the negative reciprocal of the slope of the tangent line. This will be the slope of the normal line. So again, put the slope for the normal line and put the point x0 and y0 in this formula. This will be the equation of normal line. So dear students, now this is the end of this segment. Thank you. Allah Hafiz.